let's dive right into this tactical mission briefing. Welcome to what I like to call the John Wick of Cambridge examinations. Why John Wick? Because when Paper 2 of the Cambridge Computer Science 9618 syllabus pushes you out of your comfort zone, you don't just sit there and panic. You push back. And you do it with absolute precision, with perfect answers. Today, we are mastering the ultimate survival skill in this syllabus, implementing pseudocode from structured English design. Now, I know what you're thinking. This is the boogeyman that haunts students' nightmares. But by the end of this explainer, you're going to be the one holding the pencil like a weapon. I want you to picture two very different types of students sitting in that exam hall. First, we have Alex. Alex is a classic case of the flawed approach. Faced with a complex algorithmic problem, Alex panics, completely ignores the command words in the question, and just overloads the page with raw, disconnected computer science facts. There's zero analysis happening there. It's just a desperate brain dump. Then, on the other side of the room, we have Sam. Now, Sam actually knows the material, but Sam rushes. Sam skips past the command word requirements, totally misses the specific context of the scenario, and ends up leaving massive method marks just sitting on the table. Both of them are going to walk out of that exam hall feeling pretty confident, and both of them are going to be absolutely shocked on results day. Today, we are going to deconstruct exactly why they fail and how you are going to systematically guarantee those marks instead.
What's really fascinating here is the sheer undeniable weight of this specific topic. We are looking at a massive 15% slice of your total Paper 2 marks dedicated entirely to implementing pseudocode from structured English design. You guys, this isn't just some minor subtopic you can casually skim over the night before the exam. This is a high-stakes battle you absolutely cannot afford to lose. Think about it. 15% is literally the entire gap between a B grade and an A-star grade. It is the defining margin of excellence. The examiners intentionally weight this section so heavily because it stress tests true computational thinking, not just rote memorization. You can't just memorize pseudocode syntax and expect to pass. You have to translate raw, messy logic into perfect structure. All right, let's quickly review our mission objectives for today. We'll start by tackling the 15% mission, then unlock the procedural framework, figure out how to be dodging the examiner's traps, move on to evaluating algorithm efficiency, and finally, synthesize the ultimate top score strategy. Section 1, the 15% mission. We need to begin with the core threat and the basic loadout you require to conquer this 15% mission. To win this game, you have to fundamentally understand how the examiners are assessing you. The Cambridge board isn't just looking to see if you can write a basic for loop. They are actively stress testing your brain's ability to take unstructured, real-world English and engineer it into flawless, systematic pseudocode. To beat the system, you need to engage three distinct cognitive domains: knowledge and understanding, application, and analysis. The assessment framework prioritizes analytical depth over superficial breadth. This means Alex's strategy, dumping 100 random facts onto the page, only satisfies that very first bullet point. Knowledge gets you the base mark, sure, but application and analysis, that is where the A-star is forged. You absolutely have to decode the command words. If the question specifically says evaluate, and you just state a fact, you are getting 0 for the analysis domain. It's that simple.
Section 2, the procedural framework. And hey, before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Okay, so knowing the cognitive domains is one thing, but how do we practically apply them when the clock is ticking down, the pressure is on, and your mind goes blank? We need a framework that completely eliminates panic and replaces it with cold, calculated execution. Top-tier candidates systematically execute this exact 5-step procedural framework to decompose the problem step by step. First, you identify the key elements from the structured English. Second, apply relevant programming principles. This is where you make the critical decision of whether you need an array, a while loop, or a case statement. Third, execute your analysis. Fourth, verify your results with dry runs. And fifth, present it all in perfect pseudocode format. But here is the secret weapon layered on top of all of this, the PEAL framework. Point, evidence, explanation, link. Whenever you are asked to explain your design choices in computer science, you state your algorithmic point, provide evidence directly from the structured English scenario, explain the logic behind your pseudocode choice, and then link it back to the system's overall efficiency. This is the ultimate computer science success blueprint. It's exactly how you turn a messy paragraph into structured perfection. Now, the absolutely crucial point here is the method mark strategy. This is where examiners reward your rigorous testing and clear working just as much as the final output.
Think back to Sam, who we talked about earlier. Sam rushes to write the final code, skipping the initialization of variables, blowing past the clear structuring of nested loops, all while desperately trying to get the final logic perfect. But here's the tragedy. If Sam makes one tiny syntax error at the end, that whole house of cards falls apart. The method mark strategy ensures that even if your final output has a bug, you still capture 80 to 90% of the marks simply because you systematically showed your process. You get marks for declaring variables correctly. You get marks for setting up your loop boundaries properly. Never, ever just write the final answer. You have to document your computational thinking every step of the way. Moving on to Section 3, Dodging the Examiner's Traps. Let's be real. The exam field is basically full of landmines. So let's analyze some critical intel straight from the principal examiner reports on exactly where students fail and lose those precious method marks. This quote is our primary warning. It says, providing generic, unlinked answers is a fatal error in the field. Let me give you a highly specific computer science example. Say the exam asks you to design pseudocode for a temperature sensor in a nuclear reactor. If you just write a generic while loop using abstract variables like x and y, you are going to lose marks. You must use contextual identifiers. Your variables should be named things like current core temp or max safety threshold. The examiner desperately wants to see that you aren't just reciting memorized code from a textbook, but that you are actively engineering a solution for the specific scenario they gave you. When we compare an unprepared student who just overloads facts against a top scorer, we clearly see that victory comes down to checking those boundary conditions and applying context. Look at Alex's flawed approach on the left. Alex uses generic identifiers and often applies the wrong algorithm entirely, like throwing a complex bubble sort at a problem when a simple linear search was all that was actually required. Now, look at the tactical approach of the top scorer on the right. The top scorer links every single point to the context, rigorously verifies array sizes, and tests the absolute limits of the data before writing a single line of final code. Stop scrolling, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCS and turn on all notifications so you never miss our weekly exam strategy sessions. Okay, now I need you to memorize these top 3 mistakes straight from the examiner reports so you can actively push back when you are forced out of your comfort zone. Mistake 1, wrong algorithm context. Don't write a complex recursive function if a simple iterative loop solves the problem more efficiently. Mistake 2, ignoring boundary conditions. Guys, this is the silent killer. Did you actually check what happens if the array is entirely empty? Did you account for the off by 1 error in your for loop where an index suddenly goes out of bounds? Always check the edges. And mistake 3, non-specific generic answers. If you eliminate these 3 mistakes from your workflow today, your mark potential is going to instantly skyrocket. Section 4, Evaluating Algorithm Efficiency. All right, it is time to upgrade our weapons system. We are moving from simply writing code to critically analyzing algorithm efficiency. Welcome to the interactive workshop segment of this explainer. I want you to actively engage with the data we're looking at right now. We are going to run through some rapid-fire challenges to test your analytical reflexes. First up, challenge 1, the data scan. You've got 60 seconds to extract the core trend here. If you have an algorithm with high time complexity because of deeply nested loops, but very low space complexity, what is that core trend? It's a trade-off. You are saving memory space at the severe cost of processing speed. Now for challenge 2, find the flaw. Imagine a student writes this paragraph in their exam. This algorithm is good because it runs fast. What exactly is wrong with that sentence? The flaw is that it completely lacks evidence and explanation. It's a generic claim. Using our Peel framework, you must elevate that to say, this algorithm is highly efficient in terms of time complexity, that's your point, because it utilizes a single unnested while loop. There's your evidence. Reducing the number of required iterations to process the array, that's your explanation, leading to faster execution for the user, and there's your link. That is how you get the marks. Evaluating algorithm quality ultimately demands that you consider alternative approaches and justify your tactical decisions with hard, undeniable evidence. This brings us to challenge 3, speed writing. In your head right now, you need to be able to justify why you chose your specific pseudocode structure. Higher order evaluation isn't just patting yourself on the back and saying your code works. It's about confidently acknowledging the limitations. You want to write things like, my algorithm uses a static array, which saves processing time during memory allocation, but limits scalability if the dataset grows unexpectedly. That exact level of critical analysis is what examiners are actively hunting for when they decide who gets those final, coveted A-star marks. Finally, Section 5, the top scorer's strategy. Let's move into our final debrief and synthesize this entire strategy to ensure maximum mark retention. We've decoded the command words, we've applied the Peel framework, and we've analyzed the examiner's deepest frustrations. Now we put it all together. When you master these fundamental principles, you develop a conceptual understanding that easily adapts to any curveball the exam throws at you. And listen, this isn't just about the 9618 syllabus. This level of algorithmic thinking scales all the way up from your foundational years. Whether you started with the 0417 or 0478 IGCSEs, 0983 and 0984 variants, or even the O-Level 2210, it all builds directly to this exact moment in 9618. The foundational logic of sequences, selections, and iterations remains absolutely identical. What actually changes is the complexity of the structured English and your ability to seamlessly transfer your procedural framework into entirely unfamiliar contexts. You also need to apply a time management matrix to ensure you don't accidentally spend 30 minutes sweating over a 10-mark question. So when we strip everything away, all the tactics and frameworks we've covered today distill down to exactly 3 ultimate rules for success. I need you to lock these 3 takeaways into your memory right now. Rule number 1. Secure your method marks through incredibly clear processes. Show your variables, write your comments, and document your logic step by step. Rule number 2, contextualize everything. Absolutely no generic answers and no abstract variables. Link every single point you make to the specific scenario provided in the structured English. And rule number 3, evaluate your algorithms relentlessly. Use the Peel framework to justify your choices regarding time and space complexity. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. So, before you sit down to face your next past paper, you need to ask yourself one question. Are you truly prepared to dodge the traps and test every boundary? Are you ready to hunt down those edge cases before they crash your code and ruin your grade? Take this framework, apply it to a blank sheet of paper, and prove to the examiner that you are in total control of the logic. Here's your final reminder. Subscribe to our YouTube channel, AC Exams, at acexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to acexams_IGCSE and click that bell. Don't let any another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. AC Exams, your Cambridge success starts here.